Hi again. So in this video, we're going to dive straight into the examples. So let's get some space. Okay, so let's try out one example. Let's put it as e.g. Okay, in this example, let's try. The question will be evaluate without using the calculator. I mean, you can use the calculator, but they want to see that you know how to use the rules or the laws of indices. So in this example, we have a question which is 9 to the power 1 over 3 times 27 to the power 1 over 9. So it's very useful if you know what are, let me write here, your multiplication table very well. Your 2, your 4, your 3, your 2, 3, 4, 5, 6, 7, 8, 9, yeah, and so on and so forth. So what I mean by that is you need to know that 2 square is 4, so maybe I shall create some space here. So 2 square is 4, so this is anything. Let's go to a square. This is a cube, a to the power 4. So you have things like 2, this is 2 square, which is 4, 2 cube is 8, 2 to the power 4 is 16, 2 to the power 5, this is the a, okay? In this case, a is 2, okay? So 2 to the power 5 is 32, and so on and so forth. Likewise for 3, you can have 3 square is 9, 3 cube is 27, 3 to the power 4 is 81, 3 to the power 5, 3, 4, 3, and so on and so forth. And likewise, you can do the same for 4, 5, 6, 7, 8, 9. And the reason is here. Okay, so if we are going to take a look at this example, we can see straight away that we can see familiar numbers, which is 9. You can see 27 over here. So immediately we know that this is base 3. And we are going to use 3 square, okay? Because this is just 3 square over here. This is 3 cube. Likewise, 4 is 2 square, and this is 2 cube, and 2 to the power 4, and so forth. So having a table like this is very useful at the start, but over time you wouldn't need this. It's just maybe at the start if you're not too familiar with the numbers. This is very helpful. And the reason is because let me clear this so that I don't confuse. So let me restart this as well. So if you see this is 9, instead of putting 9, we can actually do some substitution. But first, let's take a look at the question. In this example, we see that first, they don't have the same base. The base, one is 9, one is 27. The powers are also different. One's 1/3 and the other is 1 over 9. And it's multiply. So first, we need to somehow maybe change it to either same power or same base, or do something to this equation. So first, we take a look. 9 can be changed to, maybe let's change it to 3 square. So let's write 9 is 3 square. Alright, and then this is still 103. Multiply by 27. Instead of putting 27, I can put 3 cube. Okay, this is the base, 3 cube. 3 cube. And let's put the brackets. And this is 1 over 9. Okay, so now when we're looking at this question, alright, they now have the same base. But before we do anything about it, can we make this power be 1? Because we have one power inside the bracket and one power outside the bracket. So remember, we have the rule which says that a to the power m, and there's a power outside, we can just multiply the powers together. So let's just put a multiply here. Alright, so it's just 2 times 1 over 3. Okay, so it will be 2 over 3 because it's 2 times 1 over 3. Multiply by, in this case, it's 3 times 1 over 9, which 3 times 1 over 9 is 3 over 9. 3 over 9 is actually 1 over 3, 1/3, right? Okay, I'm just going to write this. 3 over 9 is just 1/3. And now let's take a look at the question. What we have base 3 over here, different powers. Same base, multiply. Do you remember which rule we need to use? Okay, the rule in this case is a times a, same base. Are the powers the same? No, the powers are different. One is, let's say, m, the other is n. So if it's the same base and multiply, we're going to take a, m, multiply is plus n. So in this case, the powers are going to add. We're going to add the powers. So it's just 3. 2 over 3 plus 1 over 3. Let me just write it out first. Okay. And 2 over 3 plus 1 over 3 is just 3 over 3, which is 1. So the answer is just 3. So in this example, we have seen how useful this table is. Maybe you can create your own, and over time you'll get used to this. I'll create another video to list it down, and over time you see 9, you know, it's 3 square, 27 is 3 cube, and so on and so forth. It's very useful to solve such questions. And the two rules that we use in this case, let's put R here, this is another rule, is if there's a power inside the bracket and outside the bracket, we want to simplify it further, we multiply the powers. And if it's the same base and they multiply, we add the powers. Alright, so that's your first example. In the next example, we'll work more on different rules for indices. See you there!